Let's do a more complicated example. So in this case, we have f of x, which is 2 cosine of x plus cosine square of x. And the problem says to graph it, to sketch it on 0 to 2 pi. Okay, that is because this is it's clearly a periodic function. Okay, so every feature that we are able to find in the period 0 to 2 pi, it will repeat infinitely many times. Okay, so we can just graph this window 0 to 2 pi and then repeat over and over like a pattern. All right, so let's start computing the first derivative. So this is negative 2 sine of x plus 2 cosine of x times negative sine of x. Okay, and then let's try to simplify this a little bit. Here it's in our own interest to simplify because we need to take another derivative. So it's important to do that. Otherwise, it will just keep getting more and more messy and we will not be able to see anything there. So negative 2 sine of x, 1 plus cosine of x. And then the second derivative is negative 2 cosine of x, 1 plus cosine of x, minus 2 sine of x, derivative of the cosine, which is the sine square, and I need to change the sign because it's a negative. And that's it. All right, so let's start with a study of the first derivative. So first thing we want to know is if there are any critical numbers. So equal to 0, that means that negative 2 sine of x, 1 plus cosine of x equals 0. The negative 2, I can get rid of it. So here there are two things that can happen, that either the sine of x equals 0 or the cosine of x equals negative 1. Okay, so let's see very carefully in the trigonometric circle. There we go. So the sine is equal to 0 here and here. So that means x equals 0 plus or minus pi, plus or minus 2 pi, and so on. Every half a turn or full turn. Okay. And then the cosine of x, so that would be the sine, equals 0. And then the cosine of x, let's use a different color, is equal to negative 1. That will happen only here. Okay, so the cosine of x equals negative 1. That will happen for plus or minus pi, plus or minus 3 pi, and so on. Only the odd multiples. Okay, but actually what we realize is that there is a repetition. Okay, so the sine of x equals 0 already covers all the bases. And also we need to keep in mind that we are concerned with the interval 0 to pi. Okay, you see what I meant with the periodicity? So we are going to have critical numbers, infinitely many critical numbers that repeat periodically. But we are concerned with 0 to pi, so all we need is 0, then pi, and then 2 pi, and that's it. So x equals 0, pi, 2 pi. These are the critical numbers. Okay, so let's box this so that we can find it easily later. Okay, so now we can do a sign chart. we are going to do the sign chart for the first derivative. And here we have 0, 2 pi, and pi. Okay, and what we have, let's look carefully at the formula for the first derivative. It's -2 sine of x. Let's actually write it down. F prime of x is -2 sine of x. Let's put it over here, times 1 plus cosine of x. So let's see the signs of all these things. So sine of x and 1 plus cosine of x. Okay, and then the derivative itself. So the sine of x, when I look from 0 to 2 pi, the sine of x is going to live in this region, right? From 0 to 2 pi, so it's going to be positive. Actually, oh, there we go. But in this region, what happens to the cosine of x? The cosine of x is for sure, 1 plus cosine of x is for sure bigger or equal than 0, right? I mean, the cosine is always bigger or equal than -1. So that's not a problem. It will only be -1 whenever we arrive to x equals pi. So actually, I can say that it's positive. And then the derivative is going to be positive times -2 is going to be negative. Okay, so here we have that f is decreasing. And then I look at the second half. Okay, from pi to pi. And in that part, the sign is negative. 1 plus the cosine is still positive, okay, because again, the cosine is bigger than -1. It will be equal to -1 only when x equals pi. So then I have positive times negative and then multiply by -2, that makes the derivative positive. So that means f is increasing. Okay, so we have decreasing, then increasing, that means that pi is a local minimum. All right, so that's for the first derivative. Now the second derivative, let's see where we have it. We need to do a sign chart for this one, for this little monster. And actually, yeah, these are too many things. Like, so what we need to do is to simplify it a little further somehow. So this is -2 cosine of x minus 2 cosine square of x plus 2 sine square of x. And actually this just gave me an idea, because there are cosine square and sine square. We can use the Pythagorean theorem and write sine square as 1 minus the cosine square. Okay, why am I doing this? Because I saw that there are cosines square and sines square, so it's kind of asking for it. Cosine square of x plus 2 minus 2 cosine square of x. And the whole thing together becomes -4 cosine square plus -2 cosine x plus 2. Okay, there we go. So here this looks very complicated, but actually it's not. Okay, because we can write, actually let's do it right away, -2, and I have 2 cosine square of x plus cosine of x plus 1, okay, equals 0. And here what I'm going to do is I'm going to call u equal cosine of x, so that I actually have u squared 2u squared plus u plus 1 equals 0, which is a quadratic equation. Okay, and actually it has roots u equal 1/2 and u equal -1. What does that mean? So that means that we want the cosine of x equal 1/2 or the cosine of x equals -1. Okay, and looking back to the trigonometric circle, oops. I don't know what happened there. There we go. So we have a cosine equal to 1/2 in these two cases. This one and this one. Okay, remember we are working on 0 to 2 pi. So the first possibility, 1/2, that is pi thirds, that will be 60 degrees. But remember, we always write it in radians. And then it would be negative pi over 3, which is 2 pi minus pi over 3, 6 pi minus pi, that makes 5 pi over 3. Those are the two angles. And so these are the first two options. And then cosine of x equals -1, which is x equals pi. All right, that's it. These are the points where the second derivative is equal to 0. We have seen those coincide with the inflection points, the changes in concavity. So let's box this to have it for reference. And with this information, we could just proceed and do a sign chart for the second derivative and then graph the function. But what we are going to do is to actually look at the graph from the calculator or the computer and identify all these features that we have discovered. Okay, I already sketched the function here. And what we can see very clearly is that the function has an absolute maximum at 0 and 2 pi. You see the line 2 pi on the right. Here I cannot point in this software. And then we have an absolute minimum at pi. Okay, you see that minimum that is kind of very flat. Okay, but it's not completely flat. The derivative is 0 only at pi. And then we have the inflection points at pi over 3. Okay, that we can see it's close to 1. Okay, you see that there is a change in concavity there. It goes from concave down to concave up. Okay, and it stays concave up from pi thirds to 5 pi thirds, which is somewhere between 5 and 6, closer to 5. Okay, and you see there also this function is symmetric respect to pi. So you can see the change again to concave down. Okay, and those are the inflection points. We can also see that it's clearly decreasing from 0 to pi and then increasing from pi to 2 pi. And with this information, we can compare with the work we did and be sure that what we computed is correct.